Imagine if high school students could learn about the automation technology that fuels the largest economy in the world. Imagine if their teachers had access to state-of-the-art professional development supporting this instruction. Imagine if a state-of-the-art laboratory provided remote access to critical technology for participation in collaborative problem solving.
There's no borders on the internet. People all over the world need to start working in a network, you know, because people from India, people from China, just like us, and we have companies that need help or, you know, want to help. And when we have problems working on their equipment or vice versa, you know, it's nice to have it so that we don't have to haul anybody around the world to help us. So basically it's instant help wherever you can get it.
If we hit that, we've got some properly. We can do it two at a time.
Mike Kraker integrates this virtual environment approach with his students at Wilmer High School. Brandon and Ed are learning automation and motion control using collaborative problem-solving techniques.
We both have strengths and weaknesses, and we basically cover for each other, you know.
I'm definitely a fan of the trial and error thing, where it's like, here's the stuff, here's a basic of how to do it, let's see what you can do with it.
When Brandon and Ed run into a problem they can't solve, their teacher has an established connection with a virtual team expert.
Automation and motion control, this is Ken.
This is Wilmer. We're ready to look through the cap station.
Okay, just a second. I've got you guys on camera here.
I thought what we would do today is go through what the overall flow of that machine is in terms of its sequence. So we'll do that by beginning with the human-machine interface that you have in front of you there, Brandon.
Dr. Ken Ryan from the Center for Automation and Motion Control, located at Alexandria Technical College, assists Brandon and Ed.
After he answers, he has immediate access to the camera here, and he can see what we're doing. He has preset camera positions, so he can look at us, look at the project, or look at the laptops. And he can control the laptops through his remote access. He can see the logic, he can check the logic, he can see our human-machine interface. Basically, he has just as much access to the machine as we do right here.
We have a connection to the expertise of the instructors at HI-TEC. I have a limited skill in this particular area, and I've been learning over the years, but these guys have been working, this is their life work, and they have some tremendous things going on at their school there. My students are able to tap in to some of that knowledge as they work with them through the internet.
Dr. Ryan shares his expertise through weekly interactive, web-based professional development classes for the high school teachers involved in the Remote Automation Management Program.
Exactly. So now if you hit the start button at this point, you're going to find out that nothing happened.
Jeff Miller, an industrial technology teacher at Owatonna High School, is one of his students.
When you teach technology, everybody knows that technology is rapid, so it's changing all the time. And for me, good learning always happens when what you're trying to teach and what they're trying to learn is in context, and it's relevant and it's authentic. And so when I can be in this office, 10 feet from my desk, and I can have access to one of the, I consider, one of the best programs in the country, and certainly one of the probably most innovative instructors, that's just absolutely huge for not only for myself but for the students here. It's a big deal.
Jeff Miller at Owatonna High School is able to use his professional development learning to offer his students the fundamental skills they need to begin an automation project.
And so you can see we have two true statements. What I'm going to do is advance this to the next step.
Yeah, right there. Can you see the valve for A, for cylinder A? Can you point specifically to it? There it is right there. Now there should be a little light, there should be a solenoid light that should go on if that is actually active.
Dr. Ken Ryan says there's a need to have some underlying structure to this type of learning process.
The social networking skills that are brought in combination with the technology that we're applying to emerging problems is very important. we see Ed and Brandon working down in Wilmer on technology that may be relatively new to them, but because they have access to subject matter experts remotely and know how to properly leverage that technology, they can solve a problem that if left on their own they couldn't do. But they really have to have those communication skills that we see them using.
There could be blockage of the air supply to the cylinder.
They have to be able to effectively ask questions. They have to be able to listen to answers. They have to know what direction that they want to go with the problem. So that whole blending of what technology they have to apply to what problem, and then what social networking skills are they using to weave that all together, those are going to be key points in how we move forward in the workforce of tomorrow.
Getting the basics from Jeff Miller allows his student to go online with the Center for Automation and Motion Control for a more advanced capstone experience. As project sponsor, the center maintains expensive advanced automation platforms which the secondary partner could not afford and cannot support.
CAMC, this is Jeremy.
Hi, this is Josh in Owatonna, and I'm working with your MAS cap station, and I'm having a problem.
Okay, any sort of idea of what?
Advanced automation students at the center receive fellowships to act as mentors to the high school students during collaborative troubleshooting sessions.
The Remote Automation Management Project allows us to produce a collaboratory between Minnesota high school students, their teachers, and our command central here at the college and the Center for Automation and Motion Control, so we can help those students learn about advanced automation technology. They're able to come in over the internet and solve problems in collaboration with a technician that's at the command center.
Yep, the light came on.
Yep, that's good. All right.
So Josh, why don't you go ahead and from your operator interface run that through a couple times just so we make sure it's working while we still have Charles on the phone.
Alright, the problem seems to be fixed. It's working now.
They can almost be self-directed in a sense. They know that when they encounter a problem, they can get on the bat phone and talk to somebody, and it's going to give them an answer. I just have to be the guy who holds the key and creates the possibility for them to really explore on their own, be in charge of their own learning, which is the whole point.
Imagine if technology educators could receive interactive, web-based, just-in-time instruction to pass on to their students. Imagine if students could collaborate online to design a solution to a problem. Imagine if all of the needed tools were at their digital fingertips. Imagine if subject matter experts from around the globe were available for consultation. Imagination
So basically, that is what we're doing with the RAMP program at our high school sites. We've provided a direct connect link from each of the high schools that we're working with to provide support and training to the high school students in the competencies of mechatronics and electronics and fluid power, PLC programming, robotics, any of the areas that's included in the system. We also provide staff development for the teachers, and we're on a direct connect link with these students. So basically, what are we doing with it? Basic electronics, basic pneumatics, electrical controls and sensors, programmable logic controllers, human-machine interface and SCADA, print reading, mechanical concepts, and assembly. So we cover all these different areas from our site using our subject matter experts to the high school sites around the state of Georgia. This is the equipment that we have kind of standardized. We use the 4 systems on the outside edge, the ones in each of the corners. These are developed or produced by SMC, and we place these at each one of the high school sites. So each of our remote sites has these 4 pieces of equipment along with a computer for each station, and they use headsets because we use a lot of voice over IP communications for the system. Everything's Ethernet network, and then we maintain the system that's in the center. This is an MAS system. We maintain it at our site, so it is available for those students to connect to via the internet to come in and actually do troubleshooting and diagnostics if need be. So our command center looks just like this. We have 8 screens. We have an instructor that sits in front of those screens daily, and he has the option. We don't use VNC as much as we used to. We still have the available, but the virtual network computing that takes place, we have a software package that allows him to take control of the students' computers on the other end, to broadcast images to those computers, to walk them through software simulations, he's got just as much control of the computers on the remote end as he does of his computer there at his desk. So he can do anything he needs to do there as far as showing them any software package or loading software or cleaning the systems up. We also use a voice over IP system, and I said that we have a hard-based V over IP phone there that's a 4-digit extension from our building to theirs, no matter where they're at. It's no long distance charges. It all runs through the network. And then we also have soft phones on each one of the computers. So each student has their individual phone that they can communicate directly to our instructors with, or they can call into a virtual conference call and actually be in the system with several other students communicating at the same time. So there may be 30 students in a session hearing a lecture, and if one person asks a question, every one of them hear that question, and every one of them hear the response by the instructor. So it's just like them sitting in a classroom, but it's live with an instructor-guided system. This slide basically shows the way we're connecting. Our post-secondary subject matter expert, or our teachers, at the top of the left corner, can work directly with a high school teacher in a professional development session, which we offer every day. The secondary teacher can work directly with his students, or the students can work directly with our instructor back at our school. So we tie in all these people together so that there's no limit to the expertise they can gather. The technical skills at the high school are now the same as the technical skills that's available at the technical college or at the community college or at the university system, wherever. And then the remote access program allows them to access equipment across this network also. So our teacher can take control of their equipment on their end and actually insert faults and for diagnostics for their purposes and vice versa. So the history of building a ramp, how did we come about this? The first thing is I saw the video that you just seen. The video was out on the internet, and I ran across the video, watched it, and I made a trip to Minnesota to go see it firsthand. Dr. Kenneth Ryan was director of the program. I went up and visited with him for 3 days and seen how they were using the system and what their purpose for it was and exactly where they were at with the system. At that time, I think they were in 3 high schools in the state of Georgia, and they also used it for some industrial training. 3 high schools in the state of Minnesota, I'm sorry. So we worked with him. We brought the idea back to Georgia and began the process of implementation. In summer of 2008, we received the original funding from TCSG and Department of Education in the state of Georgia of $300,000 to develop the pilot program. And this basically purchased the infrastructure necessary, the network ability, the servers, the screens, all the technology that was required to run the system and to get it in place in our organization. September 2008, we submitted application for a $2 million Department of Labor grant to expand the ramp model to multiple sites. November of 2008, the first ramp site came online in Tifton, Georgia, of course, right where our school is located. We are a 4-county service area, but our campus is located in Tifton, Georgia. And then in January of 2009, Moultrie Technical College was awarded $1.75 million of the Department of Labor grant we had requested to expand the ramp project. So where are we today? We started out in Tift County. We've had 2 sites. We have one system at a private school in Tifton and one at the high school. Habersham County, Georgia, Coweta County, Troup County, Forsyth County, Houston County, Rockdale, Glenn County, Floyd County, Mitchell County, Newton County, Lincoln County, and DeKalb County as our last session that we've set up. So right now we're set up in 14 different high schools around the state of Georgia. We are working with those teachers daily. We're working with those students daily throughout their school year in providing them information. Of these systems, we've expanded, it says 13, we've actually got 14 now. We've installed one, finished the installation today that I came out here, as a matter of fact. We're in 6 career academies in the state of Georgia. So 6 of these locations are career academies. 7 are just regular secondary high schools, 1 private school. We had 22 dual enrolled certificate completers. These dual enrolled certificate completers were only in our 4-county service area because due to our limitations in our service areas, we cannot enroll students in our courses from outside our service area. So the students that were dual enrolled certificate completers were in our 4-county service area high schools. We directly trained 560 secondary students statewide, and this is since 2008. We started this system in 2008. It was 2009 before we got the first site on. It was 2010 before we actually had multiple sites running. So since 2010, the bulk of these numbers have come through the year. 10 secondary teachers, 4 secondary or post-secondary instructors, and basically this is what we've created now. That high school model where you had just the high school student and the post-secondary teacher with the post-secondary student. Now we've tied all of them together using RAMP, and everybody has access to the technical skills of the other. The remote site equipment consists of 4 automated process trainers, 4 laptop computers, and we're saying 4. You could have 8, you could have 20. It just depends on how many stations you want to set up at that individual school. We settled on 4 because that works out pretty good. 4 students or either 8 students at each session, and they can double them up on the systems. 4 additional monitors. I mean, we don't use the monitors anymore. We did have an external monitor there that we used so we could broadcast our desktop to it, but we found another tool that allows us to do that. It's much more efficient. We have 1 IP phone, 1 pan-tilt zoom camera in the ceiling, so we can take that camera and rotate it around and see everything that's going on in that lab. We can see the operation of the equipment to make sure it's working correctly. We can see the students, exactly what they're doing to the equipment if we ask them to make adjustments. So it ties this back in. The purpose, the biggest obstacle of any kind of online or remote type training is hands-on. How do you do the hands-on component? This gives us a tool where we can do the hands-on component and visually verify it via the camera, and it's efficient and it's effective. And a router on their end. Basically what we're doing is we're creating a VPN tunnel from one site to the other. So all the network traffic is encrypted across the tunnel, and it's a direct internet address from our point to their point. So all of their computers and their equipment have IP addresses that are in basically a DHC pool off of a router that we have access to. So we can ping, we can control, we can virtually network every one of these computers together. The services that we provide via the RAMP, we provide daily access to subject matter experts from 8 o'clock to 3 o'clock, Monday through Friday. So from 8 to 3, someone is sitting at that command center 5 days a week. If a student calls or a teacher calls or something happens, we have somebody available at that phone to help them work through that issue or that problem. We provide daily staff development sessions with secondary teachers from 3 o'clock to 5 o'clock, Monday through Thursday. So at 2 hours a day, we are available for teachers to work directly with our instructors to make sure they're building their skill set so that they can better utilize the equipment in their labs and better prepare their students. We provide all software and all licensing for that software. We do all the network configuration and support. Basically, all we require from their site is their IT department has to provide us with a data port that connects to their network, and they have to open some firewall ports. Once we get the VPN set up, they can close some of those, but we have to have it to get it set up. And then from there, they don't have to mess with anything. We manage the computers, we load the software, we do everything remotely. We can image the computers if we need to from our location. Everything takes place with nearly no effort from the local IT department. We maintain and provide the voice over IP system. The software run on a virtual PBX system that runs on our servers in Tifton. We provide a dedicated VPN tunnel. The bandwidth for program connections, we had a dedicated fiber line run into our institution just for this project. So we maintain that network. And we provide quarterly training sessions for secondary teachers. And 1 annual customized staff development session for each one of the teachers. So we provide all of this services via this ramp program for all these high schools in the state of Georgia. I said we were in 14 right now. We've got 10 more that are interested. They're looking for the funding for their equipment because they have to purchase the equipment, and they have to pay us a fee for these services to be able to maintain this, because it is a pretty good amount of work on our end to maintain it. But it works out pretty well because we're providing an interest in automation at a high school level that feeds our programs. Not necessarily feeds Mechatronics program, but the students in Atlanta will go to school at the technical schools or the colleges in Atlanta. The schools in South Georgia will go to their respective schools. So the students are not going to leave North Georgia and drive to Tifton, Georgia to go to school. They're going to go to schools in that county. So those school systems are pretty well open to the arrangement of using our services to help develop that interest into their technical programs and to build the skill level of their existing teachers and to build their programs to help increase the capabilities of the students that are leaving their programs. The credit options for students are dual enrollment options. We have, if they're dual enrolled, they are participants or students of the Technical College System of Georgia. They're enrolled at a technical certificate at their local technical schools, not ours, or they can be, if they're in our service area, they can be enrolled in our school, or articulation agreement. Participants are students of the secondary partner. Basically, they utilize the RAMP program to teach the competencies that they teach in their everyday programs, and then if we cover those areas, they can take a test and they can actually get credit for courses at the secondary, post-secondary level. So they have the opportunity to do dual enrollment or articulation. So now I'm going to open up the floor and answer some questions.
Is it your vision that those core courses you talked about, the electronics, electrical, pneumatics, where you think we need multi-skilled technicians, that essentially the future would be that students would get this sort of preparation, whether at high school or at the community college?
Exactly.
And then if they wanted to specialize in a particular field, they could specialize, but they would all at least get this core knowledge.
See, the purpose of this is developed around our initial customers, who are the direct industries in our local service area. So in our service area, we've got companies who hire maintenance technicians or installation technicians, and they need somebody who comes in with electronics, mechanical experience, or knowledge of those systems so they can come in and diagnose and repair equipment as needed. They do not have in their budget the opportunity to purchase or to hire someone that's just an electrician special or electrician or electronics or mechanic. They have to have someone who has multi-skill. So that's where this program's developed. From here, you can expand it out to include specific and specializations from the students who complete these programs if needed.
The other question, that central facility, you know, that very sophisticated setup, do the students at the high school access that remotely, or do they have any use of that, or they just work with their set?
Exactly.
That's for the community college?
Yes. Yes.
Okay.
The host site, which is us, maintains the computer system with the multiple monitors, and we access all of our sites from that location. Now, they can come in and take over our more sophisticated piece of equipment that's in the lab area, but they cannot access the command center from there. Yes?
Curious about the IT support and infrastructure for the VPN and the connections. Did you get IT support from the IT people at your college? Did you, in your department, who's actually responsible when something doesn't work, and at what point?
My learning curve was straight up for a long time. So we've got a pretty unique group of people that work for our school, very supportive of one another. So we utilized our existing IT staff. When we were in communications with Alexandria, they were working with us to help get this set up. And some things happened there that they lost some of their staff and some of their funding, so they had to back off the system a little bit. So we had to use our existing staff to get this set up to where it would work for our system. And they helped us out tremendously. So we set up the VPN tunnels initially. So basically when we set up a site, I contact our IT director. He creates a configuration script for the router. I put it in the router. I take the router to the site. We plug it into the wall. Their IT department opens up the firewall ports, and the tunnel's up. That's all it takes.
So you configure the router on your location, you
Yes.
bring it over here, and all it needs is an internet connection?
That's all. It just needs a network connection to their firewall.
Okay, it doesn't need a public IP address?
It does. And the router, what happens is we get that information from the remote site, we get a public IP address, we get the network mask and everything, and we translate it over in through a router that we're putting on that end. It translates their public IP into an internal IP that's on our network. And we communicate. For instance, our IP scheme may be 172.29.1.1.
Right.
The others are 172.29.12.1. And we can ping the addresses directly across those routers effortlessly.
What I'm wondering is a lot of the organizations have one or maybe just a couple of public IP addresses, and everything else is like 10 dot something or 172.17. So does that create a problem? I mean,
to this point, it hasn't. Now, I'm not a network specialist,
okay.
So I'm probably not the best person to ask this question. I do what they tell me. Yeah. So I call Steve and say, hey, this is what I need, and he tells me how to do it. So,
okay.
But we haven't had any problem. The biggest problem we've had is with some of the remote sites and IT departments allowing us or working with us to create this connection. A lot of them are scared to allow this connection initially. Once they see what it's doing, it's not a problem, and we've been able to overcome that. But the majority of the sites have had no problem. Fact is, we've had some sites that's been connected in as little as 30 minutes. So it's not a problem.
What is the cost to a high school?
The cost for the equipment? The
equipment and the contract with you for support?
The equipment can vary depending on vendors, wherever you purchase your equipment from. Of course, they have the option to buy all the IT equipment from a vendor, or they can buy it from their own, CDW or wherever they want to go. But the initial equipment package for just the MAP systems, I'm just going to say probably around $30,000. And then the IT package is somewhere around $10,000, where this includes the computers and the cameras and everything. So probably for the total package at the high school, it's going to be a ballpark of $40,000 for each site. Then for our services, we charge $10,000 a year for each site. And we maintain all the software, maintain all the connections, do all the maintenance on the equipment. If something breaks, we get the part, we take it to the site, we repair it. So we do all the staff development, all the training of the students, and work through all the systems. We charge a flat rate of $10,000 per year.
Thank you.
What happens to the faculty who has to sit in front of that screen from 8 to 3 or whatever time it was? I mean, I assume there's really busy times, and then there's time when you're, I don't know what to do.
We actually we've got multiple instructors in our labs. So we have an instructor that's available for that. So it's not always one person sitting in there all the time. It could be another instructor going in and filling in.
It's kind of like somebody's coming online asking a question, and he can go over.
Exactly. So, and he's got a little headset. If somebody calls, it rings that headset, and he can run in and answer the question.
He's responsible at that time.
Exactly. But we do have people that's dedicated to that do sit in there a pretty good bit, but they're always in session. So it's not like they're just twiddling their thumbs or something. It's pretty busy.
Pretty boring.
Yeah.
Have you been approached or have thought about reaching out to the workforce investment folks, the workforce development folks in your state?
We have discussed it with some of the workforce investment, WIA is what we call it in the state of Georgia. We have a WIA representative that has looked at the system, and we have utilized this, and I'm talking about RAMP as it's being used at the high school, but we utilize this for our economic development department also to teach industrial applications to students. We actually have a system that we can take to the industry and work with their IT department to set up a VPN tunnel to that site, and then we provide customized training to the workforce on that end for whatever technology they may be interested in. So we can teach PLC program. The same thing there as we're doing with the high schools. It's just a little more complicated sometimes to deal with the IT on that end, but it still works out really well. But no, we have not worked in negotiations with WIA, but we have talked with them about the possibility of something happening.
In dealing with your industry, do you use the word mechatronics or do you use industrial automation? How do you communicate to people at the plant level? It
depends on where I'm located. the terms are different depending on where you're at in the country. So in our area, mechatronics was not a term that's well known.
That's right.
Industrial maintenance or industrial technician is what they use. So if you go further north, mechatronics is more knowledgeable. If you go out, different areas, it's industrial automation. But they pretty much everyone understands what you mean.
So you keep using their term if that's what they're comfortable
with?
with?
Yes. Yes.
Yeah. You don't
Yeah.
try to get them to
No,
understand
I don't
what
try to
they're-
make them change their mind. I tell them what I'm saying, and if they don't understand that, then I'll go to what they understand. It doesn't matter to me what it's called.
Yeah.
I just want to.
And the program at your school that your own students are enrolled in, the community college, is that, what is it called? It's called Mechatronics?
Industrial Systems Technology. Now, we are working to develop a mechatronics program for the state of Georgia, which is basically, it's an industrial systems program with a few add-ons. And then we're also looking at creating a mechatronics pathway for the Department of Education.
Okay.
So I actually got a phone call a few minutes ago concerning that, so I think we're fixing to move in that direction. I'm not seeing everybody over here, so I'll make sure I haven't missed any questions if anybody's got any. So. Any other questions? To give you a little more information, like I said, we've had the 14 sites in Georgia. We've had multiple sites come and view it from South Carolina, Tennessee, North Carolina has been over. We had some representatives from Alabama. I'm actually going to be working with a group out of Louisiana to possibly make a setup here pretty soon. We've actually had some interest from Florida. Talked with a few schools in Florida that's interested in doing some connections. I'm going next week to Minnesota, and I will be working with setting up a possible system in Minnesota in the near future. So we've got a lot of interest from around the states recently, and then we've also got some from overseas. We've got a couple of schools over in Austria that have seen the system and are interested in doing some things, and also in Turkey. Turkey is fixing to set up, if they receive their funding, they're fixing to set up 6 sites in Turkey. So it's not just a local thing, it's an international tool that can be used, and I think it's pretty cool that you could have students networking across national boundaries to build on their expertise.
With your current system, how many schools do you believe you can support with a single center that you're staffing?
We've got 14 sites operating now, and we're about at our limit with one person in there at a time. So if we increase much larger, we're going to have to put another faculty member in that. But I told them we are basically limited by the funding. So if we have 12 more sites come on, we'll hire the personnel, build the infrastructure to develop 12 more sites, or whatever we need to do. So we're not really limited on our end, other than how many people we can get to participate. But 14 is about the max on the system at any one time.
You said the cost was $10,000 per school, and what was the other cost? I know they had to buy the equipment.
The equipment package was roughly 40,000, and then for our services, that's our support, training, staff development, everything is $10,000 per year.
Per year, and
yes.
That would support a class of what? Up to 10 to 20 students?
Some people at the schools are teaching anywhere from 60 to 100 students, a school year, using this system, running them through different facets of it, and we deal and communicate with them on a regular basis. So it just depends on how the program.
I don't know.
It's not a lot of money considering what we're doing, but the whole purpose of this was to get it to where it's self-funded, so that we don't have to rely on grants and other sources to fund it. We want it to be a self-sustaining program because we want it to continue to grow. And we tried to price it at a level that was reasonable for the schools, but also would cover our expenses.
It's going to be very important to track what happens to those students. And
right.
I know it's only a small piece of
We've had a
education.
huge success with the students so far, so we're trying to keep the data and gather the data now, but it's been pretty impressive what these students have done since they've left. So. Any other questions? All right. Well, I don't have any of my business cards with me, so what I'm going to do is flip this screen, and my contact information is up here. If you have any questions or would like to contact me or get any further information concerning the system and how it can be utilized, just give me a call or an email, and I will be glad to provide you with that information.
Thank you very much.
Thank you.